Hi everyone, and welcome to this video lecture on Rhino. Today we are looking at surfaces. We're now starting to get into some of the pretty fun stuff in Rhino, and hopefully it's getting a little bit more exciting as we progress further into what this software can do. Now, for one, I know quite a few of you will be looking forward to creating interesting geometries like this and figuring out how to play with Rhino to develop your surfaces and some of the materials and the cladding systems that you're looking at for your assignments as well. So let's get stuck in. First thing to know is that Rhino very much is treating surfaces like a stretchy piece of fabric. That's a good way to visualize it. Imagine this is a piece of paper that we're stretching and molding, manipulating, and playing around with it as we go. That's the way that we look at surfaces. They have what we call a U direction and a V direction. So typically, we would imagine an x-axis and a y-axis, but because we're dealing in three-dimensional planes, we're going to be looking at a U-axis and a V-axis. So let's have a look at what that means by just making a basic surface together. So I'm going to make a surface here, just a very bog standard surface. Now, if we are to rebuild this surface, and we'll go through the rebuild command a little bit later, we see that if we decrease our U count along here, we see we've got some squares disappearing along this axis here, this U direction. If we increase them now, you'll see that we're adding in more points. And these are much like the control points we talked about in the previous video on curves. We're just adding more places to control along our surface, and U obviously running in this direction as well. V running in the opposite direction. We can see that this number is decreasing as we play there. We can increase that as well. So let's have a look at what happens in terms of our editability if we just have this planar curve which we drew there. So we've gone to our surface tools, which are over here. Remember, if we hold down Alt, we can bring them all out. And let's just make a basic surface together. So I've clicked this one here, which is a planar surface, and I just draw a rectangle. If I then go up to Edit, Control Points on, much like we did with our curves. If I try and then go and edit the control points, yes, they're editable, and I can see it does manipulate the surface, and it does change the geometry, of course. Everything is very neutral. Everything is very much blended. I'm not getting the complexity that I have with this surface over here, and that's due to the number of control points, which comes to our U and V coordinates, how many we have running in each direction, and the degree, so which is the degree, if you can think about it in terms of the dimensions. It might help you think of it that way. If it's a three-dimensional object, we can pull it in the z-axis. If it's only 1 or 2, then we can only slide along the plane, which is what this object's doing at the moment. So let's rebuild it. Type in rebuild, and I'm going to give it in a point count. I'm going to give it 10, and maybe let's go with 5, see what that looks like. Happy with that? Yes, let's bump it up a bit to 6. And we click rebuild, and we still get our control points on, but we can see we've got a lot more maneuverability now. And if I pull on one point here in space, it's going to affect a much more localized area. So the more control points you have, much like a curve, the less it's going to affect everything in the entire object because it's now more localized. Remember, it only affects the closest ones around it. So if you have more close ones, then it's only going to affect a small area. If you have a limited number of control points, it's going to affect a large area, like the plane was doing before. We can do a left to right selection, grab a whole bunch of these and start to manipulate the surface and play around with that and do some pretty cool things. And that's all just by playing with our control points, of course. This is what we call an open surface because it doesn't attach back to itself, it doesn't attach to anything else. There's no other surfaces that it's joining to. It is just an open-ended surface. Let's have a look at some lightweight surfaces. and some other types of surfaces as well. So I'll delete these for now. I'm going to make some new surfaces. So we'll go over to our curves tool, freeform control points. I'm just going to make geometry like this for now, just something arbitrary. If I then offset this curve, offset by this amount, we're done. If I then grab both of them, type in extrude curve, bring it upwards as a solid which is turned on, we now see that we have a closed surface. And it's also a closed solid as well, because we did have it turned on to solid and did have it capped. If I just drag one of those lines, extrude up, curve, and turn solid off, you can see we've got a closed loop surface here. Now this surface is though made up of multiple faces, so we can see these lines coming along in there. What if we wanted just a primitive surface? So we've got some primitive curves that we talked about before. We also have what's called a lightweight surface. Extrude, curve, and we pull it upwards like this. And this is going to be what we call a lightweight surface. If we then go up to our edit control points on, we'll see the difference between a complex surface like we were dealing with before with all those control points versus this, which is a lightweight surface. So now in this case, we only have these 2 points to manipulate, which you can see there. We've just got that one control point and the one that was down the bottom as well. So that's the difference between a complex and a lightweight. So more complexity will come by adding some more control points using the rebuild command, which we'll talk about a little bit more in a second. All right, let's look at another way to make some surfaces. I've got some profile curves here, just a primitive shape, which we know how to make from our curves primitives. And then I've got a freeform curve over here as well. What I want to do is I want to connect this polygon into this freeform curve. So first thing I'm going to do is just rotate these so that they're facing towards each other rather than on the plane using my gumball. 1990. Make sure that they're roughly where we want them to be. Gumball, yes, I want this shooting out to that one. I want to connect these vertices into this curve. Complex thing to do in CAD, not so much in Rhino. All right, so we'll select both of them and then we type in Loft. And then it's going to ask us where we want the seam. I want the seam to be down here. The seam, effectively, if you imagine you're going to 3D print this thing, where does it all join together? So once it all comes back around on itself, it's going to come back to this point. I want the seam to go that way. And we want to make sure that our little arrows are pointing in the same direction. So this one's going that way on this one, but the other one's going the opposite way, which is going to end up in a bit of a mess. Let's have a look at what that mess might look like. Ooh. Yep, it's trying to intersect over the top of itself. So we'll go back and we'll redo that, making sure that our arrows are going the right way. Type in Loft, move my seam down, and then I go over here to flip, and then I'm just going to click that curve again. So now they're both going up. They're both going anti-clockwise around their curves. Now I can press Enter. You do have quite a few options here as well, so you can start to experiment with what happens between tight, loose, straight sections, etc. And you've got some control points as well, so you can rebuild that with a higher number of control points. You can not simplify it so that it goes exactly from one to the other. Well, let's just take a look for now. All right, so we've got a pretty interesting shape here now. We've got that freeform curve connecting back to this polygon shape we had before. But what if I wanted to edit this minutely just to make it work to the eye? We've got our history tool that we talked about in the last video. So before we start now, I'm going to go to history first, select them again, go into Loft, get our seam correct, flip, make sure that's pointing the right direction, and then hit Enter. loft. Now, because we have our history turned on, I can grab that original curve and I can get in there and just minutely rotate it around by eye to make sure we're happy with that loft. And now that's looking pretty good. Nothing's too extreme on our surface here. Really kind of lovely as an object. Okay, so what happens if we want to make a loft with more than 2 curves? We've got 3 curves now, so let's type in loft, and then it says to select the curves we want to loft. So if I just select these last 2 out of order and do the middle one, let's see what happens. Click enter, looks like a loft. We have a look around. Oh, it's done exactly what we told it to do, which was to go from this one to the back one and then to the middle one, which isn't actually what we want. So it's important to know, if we Control Z, that the order in which we click a loft is important. So let's do it properly this time. We click, whoop, start again, loft, click, 2, 3. Now we press loft. Aha, much better. It's now doing what we wanted it to do in the first place. Let's look at a few of these loft options. So we have straight sections here, and we can see that it goes directly from this one to the middle one to the end one. We change it over to normal. We see we get a bit more of a sweeping curve, loose. We're a lot less tight in terms of making sure that we hit this middle one before we get onto the end curve. So obviously loose, you know what we mean there. Tight, we are 100% making sure we're hitting every part of the curve on all 3 curves there. So that's the difference between loose and tight. Obviously normal sits somewhere in the middle. Typically we would use normal for a lot of the work we're doing, but it does depend on the tolerances we're working with, which we can also deal with further down here. So we can rebuild this thing as we knew about before, adding some more control points. If we added 20 control points here, we could see what that looks like. If we added 50, we can see what that looks like. But obviously there is a danger to adding too many control points, because it will end up making it very difficult to manipulate your model later. So there is a fine balance in doing that. And then you can, of course, refit to the millimeter as well. If you really need to make it work to a specific amount, say you're 3D printing some fine jewelry detail, you can get right down to fractions of a millimeter there as well. So that's our 3 curve loft. All right, well, what if we have a surface already that we want to connect to a curve? So instead of going from curve to curve, we would now want to connect a new curve to a surface that we already have in the model. Well, you can do the same thing. So we can go from loft, select the existing surface edge, and then we're going to connect it to this new curve that we've created. We click enter, and then it's going to give us some options again, like usual with our lofts. So I'm going to go do not simplify. I'm going to this time though match at start tangents, and I can see that's now flowing much more seamlessly. If I uncheck it, you'll see it's really trying to be quite strict to get to that pentagon polyline that we have over there. So now I'm going to match the start tangent, so it's going to flow smoothly from one into the other. We can also then, if we want to have even more smoothness, rebuild with some more control points and flow into there. But for this point, I think we can just sit with the do not simplify. And that gives us a nice lofted surface from the existing point that we had to the new point we had, which is going to be very helpful in making new models from existing surfaces as well. All right, what if we know the perimeters of our curve rather than it being a bunch of curves in a row? This time we now know roughly where we want it to be, start and finish. We can then use our surface from edge curve command. So if we go up to surface and then edge curve right here, then it's going to ask for 2, 3, or 4 curves. And let's see what the difference is between those. So let's go 2 first. We'll click enter. And that's made that beautiful shape there for us. I'll push that one out of the way. Let's do that again. Spacebar to repeat the same command. This time I'm going to do 3. Nice. I've got a different curve there. And then let's do 4. Spacebar to repeat the move again. 1, 2, 3, and 4. Okay. And now we can see we have the full surface there. The beauty of this command is, as you could probably work out, these curves aren't even touching. So Rhino is smart enough to figure out, even if you make a mistake or even if you can't quite get curves next to each other, that edge command tool is going to figure out the difference for you and make your surface for you, which is very, very neat indeed. If we wanted to, we could connect those points together like so. Connect that one there to this one here. And if we then did the same edge curves command again, it would get everything perfect. So there's no gaps now. Everything's going to be 100% where we want it to be. But just so you know, if you did a join command first and join this into one closed curve, that command would no longer work. So if we go back into surface edge curves, and we see that it's not working now. It's not allowing us to select the curves. It needs to be 4, 3, or 2 isolated curves in order for it to work. So if you're having trouble with that command, probably because some of your curves are joined. Of course, to unjoin our curves, we remember from the last video, explode curves, we now have them separate again. All right, let's look at one final loft command. In this scenario, we want to connect this surface through up into this new curve that we've added and then back into another different surface over the other side. So we hit Loft, click the curves that we're trying to connect in the direction we're trying to connect them, enter, and then we get hit with a problem here. So we can see that these surfaces are trying to intersect with themselves. So if this does happen, just need to come up to here to align curves, and then we see that, yes, there is a crisscross going on. So we click the problem, which is this one here, to flip it back over, and we see it's now corrected it. Hit enter to finish aligning the curves, and now we can play around a little bit more. For me, I always like to match the start and the end, and that just means I'm going to have a smooth transition from one tangent to the next tangent. I don't need to rebuild at this point, and I don't want to split. Tight is good, so we click Loft to finish it off. And then we have it, a beautiful transition from one through to a curve and through to the other. Lovely. All right, let's have a look at an exciting tool, the Revolve tool. Go up into Surface, Revolve, and I've just made a curve over here on my front viewport in elevation. So I'm going to revolve this curve, press enter. It's asking me for the start of my revolve axis. So I want to come down to the base and notice that this is an open-ended curve down here. So when it comes back onto itself, I want it to be open. I click here, and then it's asking me end of the revolve axis. I just want it to be in the Z-axis, so it says press enter for that. And then it's going to ask me the start of my revolution angle. I'm going to have my ortho locked on. Lock it over here, and I'm going to go all the way around and back onto itself again and press enter to finish, and voila, we have ourselves a pretty cool looking vase here, all because of that profile curve has been rotated back on itself. And because history is turned on, we can go ahead and find that original curve, and we can start playing with the shape of that vase very, very, very quickly. We can now start to manipulate some of these surfaces and create some pretty interesting objects just through that Revolve tool. Let's have another look at a different type of Revolve tool, this time the Revolve Rail. Go back up into Surface, and I've got a Rail Revolve tool here. It's asking me to select the profile curve. So I've got this curve once again, open-ended. Click that one, then it's asking for the rail curve. So this is the rail. I want it to follow along around this rail. I click that one. Start of my axis is at the center point. Again, I just want it in the Z plane, so I press enter. And then I have a very, very interesting looking platter or bowl or hubcap or something. But because, as you'll notice, the rail was poking in at these 2 points here rather than a pure ellipse, it's followed that geometry around, which is great. And then again, of course, I can jump back in and select that original geometry, manipulate any of those points because I had history turned on up here, history, which will then change what's going on in my surface that I've created here, which is Pretty cool. All right, let's say you have a path like this one here, and you have a geometry, and you want to make this geometry follow along this path. To do that, we use the sweep command. So in this case, we have one rail that we're sweeping. So we sweep one rail. We have the rail that we're trying to sweep, the cross-section curve, and then we press enter when it's done. And we're happy with those settings. We click sweep, and we see that that line that we had vertically upwards before is followed along with the curvature of this one here. Another variant of that is if in the case we had two rails that we're trying to sweep along. So we have effectively three-dimensional geometry. So we want to follow this one at the same time as we're following this one. And we want this particular curve to be the thing following. Let's have a look at that. So of course we now go to sweep two rails. First rail is this one. Second rail is this one. And then we have our cross-section curve, this one here. We click enter, happy with our settings, click sweep. And if we have a look at this, we can see that that curve that we started with over here has been molded and manipulated to follow along those two rail curves that we had there. So this is particularly interesting for architecture, the sweep commands, as we would often design something along a line or a plan form or along a curve and have an element that we would want to repeat along that axis. So maybe a column we want to repeat, or maybe a fence post we want to repeat, something like that. This gives us the option to follow along that geometry as we're going and create a seamless transition to do that. All right, let's look at one more surface variation here now. It's a network surface. So say for example, we've got a hole in a surface, something like this, that we want to refill, or there's a gap between multiple surfaces that we want to fill in. We can do a network surface. So we come up to Surface, Curve Network, and we're going to select the curves that we need filled in. Press enter for that. And I can see that Rhino's trying pretty hard to make a nice smooth surface, but I can see on here there's a gap there, so we're going to have to play with some of these options. It's important to understand the vocabulary as well and what these things mean. So D obviously is corresponding to D over here. If I click from loose down to position, you'll see it tightens up that gap there. And so what position means is that wherever this curve is, the new surface we're creating must conform at least to that curve. Tangency means it must also follow the tangents where it meets at that curve. And then curvature means it must follow also the curvature as well, which is of course gold standard. We would do that if we can. Now, sometimes there might be way too much complexity in a new surface when added in by going to curvature for all of them. So you might consider that potentially, well, actually A and C only really matter in terms of their position for me. So I'm just going to keep curvature for B and C. We've also got some tolerances up here as well. So if I turn that up to 10, you'll see that it does smooth down a bit, but we've got some of those gaps now coming back in again. So just be very careful with what you're editing when you're making your network surface. Okay. All right, so now we want to talk about some roles of analysis. So we did analysis with our curves before, and there's also some important analysis tips for surfaces as well. So there's two main ones I want to talk about, but of course there are many more up in your Analyze and Surface tab as well. First one we want to look at is the surface direction. Now this is particularly important when we come to 3D printing later, so you want to make sure that you've got this down pat. So Analyze and then Direction. Selecting our objects, we're going to select all of these surfaces that we have here, and we can see that we've got some white arrows, some red arrows, and some green arrows. The most important ones when we get into our 3D printing later are the white ones. These are the surface normals, and what that means is that at any given point, wherever these points are taken, the perpendicular direction to that exact spot. So for this surface, perpendicular from this straight line here would be upwards in the z-axis. Or if we're further along the curve, we can see that perpendicular is going in some different directions over here and around over here. It's always perpendicular to wherever that spot is, and that's our normal. But effectively what it means is that upwards away from where we are right now is the top, and the underside here is the bottom. Now, what's going on at the moment is correct. If, however, we have something like this, where we have one surface is up here and another surface is down here, we're going to be telling the 3D printer some confusing messages that this is the inside here and this is the outside here, and it ends up being a problem. So we do need to always check that our surface is correct, and that was just through Analyze and Direction. And you can also change the normals just by clicking anywhere on the surface. Will change the direction of the normals for you there. Once you're done, hit enter to finish. Another surface analysis treatment that we use is the zebra, which is under Analyze, Surface, and Zebra. Select objects that we want. I'm going to again do all 4 surfaces. Now, zebra you might think looks a little bit funny, and you're correct there. If I change the stripe size to thin, we can see maybe a little bit easier. What this is telling us in terms of the analysis is how well the edges are matching up to one another. So we can see here that this edge really isn't matching at all. We've got this black joint, and then it has to run all the way this way before it starts to come around again. Doesn't matter which way we look at it, it's never really normal. And then this one over here as well, these squiggles should line up perfectly. And in some points here, we can see the lines are working to match together, and other points they're completely off. And if we turn this off, we can see why. We've got a peak here with a trough over there, and vice versa on this side. So they're really not matching well as an edge condition. And this is again going to become a problem for us when we're 3D printing later. So we need to make sure we know how to fix this. So the first command I want to show you is the blend command. So to make it a little bit more obvious, I'm just going to move this surface away a little bit just using my gumball. Then I'll type in blend and then go down to blend surface. It's asking me what's the first edge. So this is my first edge. This is my second edge, and then we can see it's now blended the two together. We talked about these before, position, tangency, and curvature. So if I change them to position, we can see that it's just making sure that our two edges are meeting each other. We're still going to end up in the same boat, that our curvature isn't talking to one another, the edges aren't talking. Tangency is going to do a little better. It's going to make sure that the tangency of this arc is going to meet, if we have both selected, the tangency of the other arc. So this one's trying to go this way, and this bottom one is trying to go upwards. So this is effectively mediating the two. And then of course, curvature, our gold standard, is going to find or interpolate the curve between the two of those and balance it out for us nicely. We can bias it one way or the other. So if we want to turn it up this way, it's going to push more towards the other side, or we can push more towards this side. Got quite a bit of control there. Then we click OK. And effectively, that's going to make sure that one surface is blending nicely into the other surface. It doesn't have to be simple geometries though. We can still do the same thing on some complex surfaces like these two. So let's try that again. We go blend, surface. I want this edge to match up with this edge here. Move the dialog box out of the way, and we can see that we've got some surface control here. And because we've already got curvature selected for both of them, it is trying to match up the curvature for both. Now, because we're quite close together here in terms of these edges, it's going to get pretty intense trying to mediate some opposing curves, which we have here. We've got a peak here and a peak here and a trough here and a trough here. So we will end up with lots of control point curves and lots of lines going over the top of each other, just trying to make it work. So there are some things you could do before this move, like you could go in and mediate some of those by using our smooth tool. Remember we talked about smooth before, we could smooth down these edges. And you could also just try and get your curves working nicely. Or ultimately, if you move this further away, and then we go blend surface again, this one goes to this one, we can see that we have a much smoother transition between the two. And click OK to finish. So those are some options there, really cleaning up your model, making sure it's ready to go to 3D print, and also a very helpful tool in lofting one surface to another in a nice smooth way, and that's the blend tool. All right, so we've now finished blending our surfaces together. We've got this surface which connects seamlessly into the other surface that we have over here. This does present a new problem for us now though, because we can see we've got a lot more control point curves, all of these lines going across in our U direction, than we do on either side of here. So none of them are matching up at the moment. We do have one way to resolve that, and that's by using the merge surface command. So we go up into surface editing tools, and we've got match and a bunch of other tools we use here. Let's go merge, and it's asking for a pair of surfaces. I click those, and I now see that it's given the complexity that we had on this middle strip, this middle ribbon is now gone over to here. And let's do that command one more time over here to match this one. And we now see we have the same U values going all the way along here. So that complexity is now equal the whole way along the surface, and it's now just one surface. If we click on this, we see one open surface added to selection. But you might say, well, that's fine, but I didn't really want that much complexity. I was happy with where this one was before, and these other two were not quite right, but I didn't want this much. Now it brings about the rebuild tool. So if we type in rebuild, like we did at the start of this video, and click on our surface, we now have the ability to change our U and V count. We can see the U is way up high right now. It's 258 at the moment. Bringing it down to 14 is probably going to smooth it out too much. Let's have a look. Yeah, I'm losing a little bit too much of the geometry that I wanted there. So let's go back to that. We'll do that command again, rebuild. And I want to this time, let's try and see what 100 looks like instead. And we rebuild that. And smoothed it out a bit, but we still have a lot of those original peaks and troughs. I'm actually going to be pretty happy with, let's say 50. That's good. So I've still got my peaks and troughs, but it's going to be a lot easier for me to edit now. If I wanted to turn my control points back on, like there's a lot less for me to grab. There's still a lot here, but it's a lot easier than 250. And that's the rebuild command. All right, now let's say we actually did want to smooth some of these peaks and troughs out even more than that. We can type in smooth. And this brings up our smooth command, which is very much the same as our smooth curve. We've got our smooth factor, which we can jump up here and increase that. And the more we increase that, it's going to increase the amount of smooths per step. And then the number of steps is the number of times it will iterate that command over and over onto itself. Smooth, 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 smooth. 75 times we've got here. And if we click OK, we can see that that has smoothed this right out, taken out some of the peaks and troughs there. Okay, let's have a look at some other tools that we can use over the top of this surface. Now I'm just going to create some simple geometry on the page here now. I've got a little rectangle, I've got an ellipse. Actually, let's just go ahead and use a circle. And I want to make an extruded curve which runs underneath this. So let's just go under here. I'm going to extrude it upwards. And let's go to 200. I'll make sure that that's slicing through, so I'm going to push it through. Okay, you can see that's definitely slicing through that. Now, what we want to do is have a look at some examples of how to trim our surface by laying some objects, some curves over the top of it. Let's have a look at those now. So, jump in here, I can see that these curves are sitting well above my model. And I'm going to use what's called the split command. So we type in split. And the object I want to split is this surface. And I press enter, that's all I want to split for now. And then I want to get some cutting objects. So let's have a look at this circle, the square, and the extrusion that we made there. Now, what we see here is that if we have a look at these isolated objects, we've actually gone ahead and split these objects away from here. So we can move them away now. We've got those objects as editable individual elements. One thing that's important to note is if we jump over to our top view perspective page, is that depending on what plane your geometry is in when you do the splitting, will impact the actual split itself. So let's undo that and I'll give you an example of what I mean. So let's take this curve that we had before, and now I'm going to rotate it along its axis like this. And then let's do that split command again. Split, objects to split, use my circle, and then it's done. Oh, sorry, split, objects, circle, done. And then we can see it hasn't lined up at all. My circle's there, but the cut it's doing is going way off to the side. You might be wondering what's going on there. Well, if you actually have a look, it kind of lines up closely to that. And that's because that is the direction of the plane. So whatever plane or whatever angle you have your curves in when you do your split is the angle that it's effectively going to push all the way through. So if you imagine this circle that we have here striking a cylinder that pushes all the way down through to our surface over the other side, that's how it's going to cut through it. So it's going to create a weird shaped slice like that, going through at an oblique angle. So you might want to do that. It's up to you. You just need to know that the plane in which you have your cutting path is the direction that it's going to cut through. Now, let's say we wanted to do some cuts, but we don't actually want the inside pieces. We just want to trim them away. You've guessed it, trim. So this time we want to select our cutting objects, curve, and we've got our square as well, and we've got our ribbon. Press enter. And then now it's going to ask us where we want to cut away. So I'm going to click inside this circle here, inside this square here, and outside this arc here. And we can see that it trims each one of those away. So I've now used that circle to trim exactly down inside my surface here. That square is doing the same, and this ribbon has trimmed off that edge piece as well. So it's the same as your split command, but it deletes the objects. One of the beauties of Rhino, however, is that even if you've deleted these objects and you've done a whole bunch of work since then, you don't need to Command Z all the way. There is a memory to these trimmed surfaces. So we can go to untrim, select the edges to untrim. If I click on this edge here, it's going to perfectly put it back in where it was. All right, let's say we want to do some splitting with some more complex surface geometry. So this isn't my jug. This is one of the jugs from the LinkedIn learning course, which again, I highly recommend should you be struggling with any particular part of these videos. We're only going through very, very small chunks of Rhino, but if you want more detailed versions, do jump over to LinkedIn Learning. There's lots on there for you as well. But you know how to create these already. We've done all of this in today's video. This is a revolve surface. Remember, you create that sectional geometry, you revolve it around the Z-axis and you create this part of the jug. And then we have some lofts going on over here. And that gives us our two elements which have then been joined together. And we've got a base which has been filled in or capped in under this side here. So these geometries are currently joined together. And if we wanted to do our split command, which we have there, and we wanted to do our split along here, we can't actually select this jug because we have multiple surfaces joined together. So before we can do any editing, we need to explode. So same as we did explode on our lines with our curves in the previous video, explode also works for surfaces. So now we have 1, 2, and down the bottom, 3 surfaces. All right, so now we can start to experiment with some of this geometry here. Let's say I want to do a split in here because I want to make this neck a little bit taller. Right click, wireframe. Okay, now I'm going to be able to see inside there. Again, we go into split, splitting this object, isocurve, And now we're going to be able to get onto that quadrant, which is inside here. There it is, quadrant 1, quadrant 2. Okay, we press N to finish. I'll just change this back to shaded so we can see what we're doing. And we can see we now have this split, or you can almost call it a lid. We can pull that off there. We can see that our jug is now separated into 2 different elements. So I want to now connect these 2 separate parts together. In order to do that, we've got a few different options. First thing I want to try is extension. Same command as we use with our curves, but I want to extend a surface. I want to extend this surface to meet up with this one here. Extend surface, just this one down here. Edge to extend, and then we want to extend it up to this point here. Perfect. And then this one here, we want to extend up to this one here. Great. So we zoom out a little bit and we can see that we now have extended the neck of our bottle there. All right, let's look at another way that we can stretch this neck out. I'll go back out into here. And I'm just going to put this on wireframe for now so I can see inside my jug. All right, so jump over to our transforms box and then stretch is the one we want. Here we are. It says what objects do we want to stretch? I want to stretch the jug. Enter, start of my stretch axis. Now I'm going to do what's called an elevator click. So I actually want to click somewhere here, but in the middle. It's really hard for me to click in the middle of the axis because there's nothing to click against. So what I can do is I can zoom in down the bottom here. I've got center turned on over here and most of everything else turned off to make it easier for me. I hold down Command or Control, then click for center. Then it's going to allow me to raise my starting point inside here. So I can jump over to my front view over here. And I want to stretch from close to the top here. And then with my ortho turned on, I only want to stretch a little bit in there just to keep the curves nice and smooth. Then if I jump out to here, I can see I've got a full range of stretch going out here, and Rhino is going to automatically sort the curves out for me. I click there and that's finished it off. And I can see I've got a much longer neck here in the curve. It is quite abrupt, this change, so we might want to do some smoothing out to figure out what's going on with that curvature. We can always do a split here and go back to the original method that we were doing before to make sure we've got a nice tangential curve, but we can see how the stretch tool works. Let's have a look at one more transform tool, just to have a little bit of fun. We go over to transform and then bend. And we'll see what happens when we bend this object. So again, let's click this one, enter. Then I want to get the start of the spine. I'm going to do my little elevator click again, Command or Control and then click. And I come over to here. I want to do most of my bending just below the base of this guy here. And I'm going to bend the full range of the neck. Now if we jump out to perspective, we can see that it's kind of like we've turned this thing into modeling clay. We can push and pull and do whatever we want to do in this viewport here to really manipulate this model. We've got a huge amount of control. And I'll turn the ortho off just to make it a little bit smoother so you can see what I'm doing. So I really can stretch this all the way down here onto itself, or I can bring it down, bring it in, do whatever I want to with the bend command. And you can really have some fun and make some pretty interesting geometries with the bend command. So let's jump over to perspective and see what that looks like now in our shaded view. And there it is, pretty cool as a geometry, and that was all just from a stretch and then a bend. And it's quite different to what it was before. And there's a few tools up here in the transform. So there's twist, bend, taper, stretch. We could do a whole bunch in there, and I want you to have a play with that as with everything. That's all for surface now. We've looked at quite a lot of things today in terms of what we can control. We're lofting, sweeping rails, making curve networks. We're extending surfaces. You can play around with filleting as well. Same as what we did in the video last week, filleting curves. You can fillet your surfaces as well to make sure that you've got all your edges looking good. Likewise, you could chamfer them if you wanted as well. We've got the blend command. We've got matching and merging that we looked at as well. Got our analysis so that you can figure out where your direction is. You can have a look at the zebra as well. And then of course the transform tools as well. So quite a lot to play with in the surfaces, and you'll find that most of your time will be spent experimenting with surfaces and making either curved surfaces or solids work for you. Up next in the next video, we are going to be looking at solids. Before then, have a play around, mess it up with some of the surfaces and enjoy. We'll see you shortly.